Hi, welcome back to Engineering Drawing. I am your Dr. Vasu. We are going to see the projections of straight lines now. If you want to learn this and many more interesting topics, please do subscribe this channel. And if you like this lecture, please hit the like button. That will keep me motivated to do many such videos in the future. Now let us see what are the different types of straight lines and how to represent them. So if you take the straight lines, they come up in different cases. First one, a line parallel to both the reference planes, and the second, perpendicular to one reference plane, and automatically it will be parallel to the other. Okay, and inclined to one plane and parallel to the other. And last, finally, we have inclined to both the planes. So let us take up each case separately, and we'll see how the projections of straight lines are represented. First, let's take up the parallel to both the reference planes. So let's take an example. A straight line of it's 100 mm long, that is its actual length, is parallel to both the HP and VP, horizontal plane and vertical plane. It is 60 mm above HP and 40 mm in front of VP. So actually, the some reference points will be given. Line means it has two ends, and initially you will be given the position of at least one point. Suppose if you call it as AB, the position of A or B will be given, and let us start representing this. Suppose if you take the vertical plane and horizontal plane like this, the line is parallel to both the planes. We call both the ends as A and B. Suppose if you are looking in the front side of the line, you get the front view on the vertical plane that is parallel to the reference line. And here this projection is obtained from the reference line or from the horizontal plane at a height which is equal to the height of this line above the horizontal plane. So we call it as a front view or A dash, B dash. We know that. And when you see this line from the top, its projection or the top view is obtained on the horizontal plane like this, and it is again parallel to both the reference line or vertical plane like this. And coming to this distance, how much the line is distant from the vertical plane is visible in the top view also. The top view, the projection in the horizontal plane is at a distance some x, suppose. This x is nothing but the distance of the line from the vertical plane. So it is visible in the top view. We call it as AB. Small letters are used to represent the top view. And here if you draw the projectors onto the reference line, the projectors appears like this in the top view as well as in the front view. Now let's take the reference line called XY, and because the line when it is parallel to one plane of reference, suppose if it is parallel to vertical plane, in the front view we see its true length or actual length. So here the line is, I'm taking up it as parallel to the vertical plane. So in the front view we should be able to see the actual length, that is 100 mm. And here it is 60 mm above HP, the height of the point, height of this line above the horizontal plane, that is in the front view we see the height from the reference line. So this line is at a height of 60 mm above the horizontal plane like this from the reference line. And you see the true length, actual length of the line in the front view. We mark them as A dash, B dash. Now, and 40 mm in front of VP. So because it is parallel to VP also, in the top view, it is parallel to the vertical plane. So in the top view also, the line projection is obtained parallel to the reference line here at a distance of 40 mm. This distance is 40 mm and mark it. So in the top view, we will be able to see the actual length 100 mm. So this is 100 mm and this is the same. So we mark it as a B, small letters. These are the projections of the straight line in the when the line is parallel to both the planes. So in the front view, mark this line, this is the final projection of the line. Only the final projection should be highlighted. All the other lines should be thin. Okay, so show the dimensioning like this, the front view, right, top view, and the actual length of the line. So once you represent all these data, the problem is over. Now, let's take up another problem. A straight line of 100 mm long, that is, its a true length is given, is parallel to both HP and VP, parallel to both the planes. It is in VP, it is in the vertical plane itself. Entire line is in the vertical plane like this. So this is the vertical plane. The entire line is in the vertical plane and is also parallel to VP. Okay, so parallel to VP means parallel to HP also. That is parallel to this horizontal plane like this, parallel to the reference line. And it is in VP 60 mm above HP. This distance is 60 mm. Now you are asked to draw the projections. So draw the reference line, right? 60 mm at a height of 60 mm, draw a line parallel to the reference line, because we will be able to see the actual length or the true length of the line in the front view. So mark 100 mm line here, which is parallel to the reference line, and this height is 60 mm. So mark 60 mm here, and a line of true length is drawn in the front view. Coming to the top view, when you see this from the top, the line, because it is in the vertical plane, when you see it in the top, its projection is obtained on the reference line itself. So on the reference line, you get the top view. Mark it as A, B, small letters. So this is the front view of the line. This is the top view of the line. And show the data given here. Okay, the height above the horizontal plane and its true length. Next, its true length is again given here, 100 mm long, is parallel to both the planes. It is in HP now. Earlier we have seen the line in the VP. It is in HP now, 40 mm in front of VP. That means, and also because it is given here, it is parallel to VP. Now let us see. The line is parallel to VP means like this, parallel to the reference line, and is in HP. The entire line is in the horizontal plane. That means both the ends, A as well as B, both the ends are in the horizontal plane. That is the meaning. Now draw the reference line. First, you can draw either the top view or the front view, right? If you want to draw the top view, the line is at a distance of 40 mm in front of VP. If you want to draw the front view is obtained on the reference line. When you see it in the front view, its front view is obtained on the reference line here. So we want to draw the top view here first. That is 40 mm in front of VP. We draw a line parallel to the reference line first and mark 100 mm, because we see the true length in the top view. Mark 100 mm line here and mark it as the top view, A and B, small letters only. This is the top view. It's over. Now we want to draw the front view. Where is the front view? When you look at it in the front, this, because it is in the horizontal plane, its projection is obtained on the reference line itself. So on the reference line from A and B, draw projectors and mark A dash, B dash and join it. This is the front view and this is the top view. Okay, because the line is parallel to both the planes, when you see its front view or top view, it gives both the views, gives true length of the line. Now, suppose we take another line here, a straight line of 100 mm long, parallel to both the planes again, 50 mm below and 30 mm behind VP. Can you tell in which quadrant it is? Yes, it is in the third quadrant. So when it is in the third quadrant, that is below HP, below the horizontal plane, anywhere it may be here or here, but behind VP, this is the vertical plane. Behind, that means behind VP here. So it is somewhere here in this. Okay, that means it is in the third quadrant. And how it is? parallel to both HP and VP. Okay, and so this is the line. It is parallel to this HP as well as VP. Now, what is meant by parallel? How do you say this line AB is parallel to VP? The meaning is, point, if you take this point A, it is at a distance of suppose some 50 mm. If the point B is also at a same 50 mm distance from VP, then that line is said to be parallel to VP. Suppose if the point is A is at a distance of some 40 mm from the horizontal plane. This distance is A is 40 mm from HP. If B is also at a distance of 40 mm, then this line is said to be parallel to HP. Okay, that is the meaning of a line parallel to any reference plane. So here this it is 50 mm below HP means both the ends are 50 mm from the horizontal plane. This distance as well as this distance is 50. 30 mm behind VP. So from here to here 30, and from B to vertical plane also 30 mm. Okay, now let's draw the projections. So here let us draw the front view first. When you see it in the front view, first of all you have to be clear with where will be the projection, its front view, and where will be the top view. Because it is in the third quadrant, the front view will be below the reference line and the top view will be obtained here on the horizontal plane, and the horizontal plane is rotated like this. Okay, in the back it is rotated in the clockwise, and this is also rotated in the clockwise here like this. The projection obtained here comes on the top, that is above the reference line. So front view is obtained here below the reference line, top view is obtained above the reference line. Now let us draw the front view. Mark a distance of 50 mm below HP. This is a horizontal plane, you can call it as in the front view. So from here mark 50 mm distance. We have drawn projectors at a distance of 100 mm long. Okay, now we mark 50 mm distance from the reference line. 50 mm, we draw a line, construction line is drawn actually, and now because this is the actual front view 100 mm long, mark this as the A dash B dash. The front view has come below the reference line because it is in the third quadrant. So this A dash B dash is the front view of AB. Now this projection is obtained here on the top view on the reference line. It's something like this, which is parallel to the vertical plane or parallel to the reference line. So once you get the projection here on the horizontal plane, rotate it. So when you rotate it, what happens? This line appears here like this, parallel to the reference line here, AB. So it is at a height of 30 mm because this distance is 30 mm, okay, from the reference line, 30 mm. At a height of 30 mm, we draw a horizontal line parallel to the reference line. Okay, at a height of 30 mm, we draw the line. Now, how to get this top view? Draw a projector from A dash, projector here, and from B dash here. Mark these points, this one as A and this one as B, that is the top view. Join this line by a straight line and highlight it. So the final top view and the final front view are highlighted. So these are the projections of the straight line. Okay, now. So this you may call it as third angle projections because the line is taken in the third quadrant. The projections are called as third angle projections. Now, suppose a line is in both HP as well as VP, in both the planes. How is it possible? Yes, it is in the reference line itself. So when it is in the reference line AB, when you see it in the front view is on the reference line itself. When you see it from the top, it is also on the reference line. So how will be the projections? Draw the reference line. Mark a 100 mm long line because its true length is visible here. Draw a 100 mm long line and mark it as A dash B dash, the front view. Also, the top view coincides with this. You need not draw any projectors. Already, the point is itself is in the reference line. This is also on the reference line. So, AB also these points. The top view is also coinciding with the front view, and this is AB. So, the front view and top view both coinciding with each other, and these are the projections of the straight line. So, here we have seen the line when it is parallel to both the reference planes. In the next video, we are going to see a line when it is perpendicular to reference line. Okay, hope you had understood this topic very well. If you have any queries or doubts or any comments you would like to, please do comment and do subscribe the channel. Thank you.